And now I sort of feel bad that we've been doing double integrals without much theoretical basis for how they work. Yes, I agree. That's poor form. So let's talk about a Riemannian sum of two variables, or of a function of two variables. If we divide the plane region R in the xy plane into small rectangular pieces with lines that are parallel to the coordinate axes, see, like I did here with this one. See, little tiny, these are little squares. But, well, they could be rectangles, we don't know, but we're making a partition of the region as this figure shows. We imagine there's a function f of xy that's greater than or equal to 0. Two variables defined on the region, we can approximate the volume of the solid formed by the region as the bottom boundary, and the upper, the top, is formed by this surface that's above that bottom boundary. So we use f of x sub I, y sub j as the height of the rectangular solid above the small rectangle where x is between xi and xi plus 1, and y is between yj and yj plus 1. In other words, maybe this box right here, right? Or this little square, actually it's a rectangle, and the function is somewhere above that. And so we're going to find the volume of that rectangular solid, and then add all those up and make a Riemannian sum. So what happens is the volume of that piece is delta xi, delta yj, that would be length and the width of the bottom of this rectangle, times f of xi star, y of y sub j, sorry, f of xi star, y sub j star, and what that is saying, that's the height of some point, interior point, or even on the boundary of the particular rectangle we're talking about. That's the height of the box. And so this xi star, yj star is just some point in that ij rectangle, but I'll just call it this for simplicity's sake. And so the sum of all those rectangular solids is called a Riemannian sum. Now it's a Riemannian sum of a function of two variables, and is an approximation to the volume we are looking for. So it is this double sum, right here it is. The volume is approximately equal to the sum of those delta xi times delta yj times f of xi yj, meaning the height of the box above this particular rectangle, where this is the base of the rectangular solid. Notice our subscripts, j going from 1 to n, I going from 1 to m, I going from 1 to n, because they don't have to be square, and they don't have to be, there doesn't have to be the same number in each direction. So that is now, we now have our theoretical basis for the idea of a double integral based on this Riemannian sum. That does feel better now, doesn't it?